Good day to all. This is grade 12, unit 4. The topic what we are going to discuss today is circular motion. Objectives of the lesson. When you have completed this session, you should be able to understand what is uniform circular motion, and you can understand what is meant by angular velocity, and you can distinguish linear and angular velocity and can discuss the relation between them. At the end of the session, the students will be able to understand that a resultant force is required to maintain a circular motion, the name of the force, examples of such forces, and its direction, etc. This topic is one of the important topic coming under Unit 4. The students need some prior knowledge. That means students should be familiar with some equations of linear motion and Newton's laws of motion. Circular motion. Circular motion is frequently observed motion in nature. It is a special case of elliptical motion, such as the orbiting of planets under gravity. In physics, circular motion is a movement of an object along the circumference of a circle or rotation along the circular path. It can be uniform or non-uniform. From the animation given, you can easily differentiate the two different types of circular motion given. Let's see some common examples of circular motion around us. A playground roundabout, an artificial satellite orbiting the Earth at constant height, hour, minute and second hand of clock, the ceiling fan's blades rotating around a hub, rotation of Earth around in its own axis, electrons movement around the nucleus of an atom are common examples of uniform circular motion. Uniform circular motion. It is a specific type of motion in which an object travels in a circle with constant speed. So remember, speed of the motion remains same. Speed is a scalar quantity. It's having only magnitude and there is no specific direction. So if the object start its motion with a particular speed, for example 10 meter per second, throughout the motion that speed remains the same or that magnitude remains the same. The radius and the time period also remains the same in uniform circular motion. Let us discuss about an important physical quantity of an object in uniform circular motion, velocity. Velocity is a vector quantity. It depends on magnitude and direction. If you consider only the magnitude, it's called speed. The speed of particle in uniform circular motion remains same. That means the magnitude of velocity remains same. Then what happens to the direction of velocity? So here the direction of velocity is changing continuously. At each point the direction is different. So the direction of velocity at any point is always tangential to the circular path at that point. Remember, only direction changes, the magnitude of velocity remains same. So I can say velocity of the particle is changing. If there is a change in velocity with respect to time, we can say object is accelerating. So all uniform circular motion object should have an acceleration towards the center. It's called centripetal acceleration. Remember, its direction is towards the center. The word centripetal represents center seeking. Acceleration and velocity will make an angle of 90 degree always. So all object on the surface of Earth is accelerating towards the center of Earth even if those are at rest. It's due to the rotation of Earth. If there is an acceleration, there should be a resultant force according to Newton's second law of motion. The direction of acceleration and the resultant force will be same. So there should be a resultant force or a net force will act towards the center if an object is acting or if an object is moving in a uniform circular motion. This force is called centripetal force. Actually, this force is keeping the object in uniform circular motion. Remember, the direction of centripetal forces towards the center of the circle. Depends on the situation, different forces are providing the centripetal force. For example, revolution of Earth. The necessary centripetal force is provided by the gravitational pull by Sun on Earth. The electron's revolution around the nucleus. The necessary centripetal force is provided by the electrostatic force. Consider an object moves along a straight line. Then how do we make it to move in a circle? You have to apply a force which is perpendicular to the direction of velocity. Remember, the force vector and velocity vector should make an angle of 90 degrees. Then the object starts to move in a circular track. So an example is given here. An orbiting satellite requires centripetal force. You know the centripetal force is provided by the gravitational pull of the planet on the satellite. So that gravitational pull or force should act perpendicular to the direction of velocity of the satellite. This is the minimum condition or required condition for an object to continue in uniform circular motion. What would happen when centripetal force is insufficient or absent? If the required force to keep the object in uniform circular motion is absent, the object will continue in its straight line motion because there is no force required to change the direction of the object. So it will move along the tangent with a constant speed. Let's discuss some examples of centripetal force. The Earth and Sun, or revolution of Earth around Sun. You know, it will take 365 days to complete one revolution. Then which force is keeping Earth in the same circular track? The answer is gravitational force or gravitational pull by Sun on Earth. So the direction of gravitational pull is towards the center of the circle or towards Sun. Then why the Earth is not going towards Sun? Gravitational force acting on Earth is just enough to change the direction of velocity. The function of centripetal force or gravitational force is just to change the direction of velocity, nothing more than that or nothing less than that. What will happen if gravitational force acting on Earth is slightly greater than the present value or than it is now? Definitely the Earth will go to the direction of Sun. What will happen if this value is less than the present value? Definitely the Earth will move in a direction of tangent with a constant speed. Let's have a discussion of another example of centripetal force, a person on the Earth. Consider the rotation of Earth in its own axis. The time period of rotation is 24 hours. So each object on the surface of Earth also in rotatory motion with a time period of 24 hours. So consider a person on the surface of Earth. So which forces are acting or which forces are providing the necessary centripetal force to keep him in uniform circular motion? So consider the free body force diagram of the person. There are two forces acting on the person. One is normal contact force and another one is weight. So which force is greater in the situation? Definitely weight is greater than normal reaction, because the force which is acting towards the sender will be greater because the resultant force is acting towards the sender. So the resultant of weight and normal reaction is providing the necessary centripetal force to circulate or to move him in uniform circular motion. So the resultant force is equal to weight minus reaction force, or that resultant force is called centripetal force, that is equal to weight minus normal reaction force. So this is the example for two forces resultant provides the necessary centripetal force. Let's have a discussion of another example of centripetal force, a conical pendulum. Consider a mass which is attached to a string and it is in uniform circular motion in a horizontal track. Then which force is providing a force to keep this mass in uniform circular motion? So you have to draw a free body force diagram for the mass. Only two forces are acting on the situation. One is tension in an inclined direction and another force is weight acting vertically downwards. Then which force is acting towards the center, or which force is providing the necessary centripetal force in this situation? The answer is here. You have to split one of the vector into two components. Here you can split tension into two components because weight is acting perpendicular direction. So after splitting, you will get two components, and the component which is acting towards the center definitely will provide the necessary centripetal force. So here T sin theta is providing the centripetal force and T cos theta will balance with weight. So in this situation, only a component is providing, or a component of a force is providing the necessary centripetal force. From the previous examples, let us have a conclusion about centripetal force. Centripetal force can be provided by a single force, for example, the gravitational pull or electrostatic force, or more than one force but in the same line. The example is the person on earth. The person experienced two forces, weight and normal reaction force. So the resultant of weight and reaction is providing the centripetal force, and the force which is acting towards the center will be greater always. And the third situation, a component of a force provides the necessary centripetal force. Example, conical pendulum. Equations of uniform circular motion. Linear and angular speed. There are two types of speeds for a body in circular motion. Number one, linear speed. So it is actually a common speed, like total distance traveled in a given time. So its distance over time, its unit is meter per second. Another one is angular speed. Here it is total angle covered in a given time. So you can represent the angle as theta. So the angular speed symbol is omega. That omega is equal to theta divided by t. Look at the unit of omega given. It is radians per second, because we can express the unit of angle in degrees or in radians. So the convenient unit is radians. That's why we are using radians per second as a unit of angular speed. Linear velocity. So linear velocity is the total distance traveled in a given time. So the total distance traveled in a circular motion, or for one complete circular motion, the total distance traveled is equal to the circumference of the circle. So it is equal to 2 pi r, and the time taken to complete one circular motion is called time period, that is represented by t. So the equation for linear speed is 2 pi r over t. In terms of frequency, we can write this equation or rewrite this equation as 2 pi rf. Angular velocity. Angular velocity is the total angle described within a time t. So for one complete circular motion, angular velocity omega is equal to 2 pi over t. You know, for one complete circular motion, the total angle described in degrees is 360, that is equivalent to 2 pi radians. In terms of frequency, omega we can rewrite as 2 pi f because 1 by t is frequency. Comparison of angular and linear velocity. Consider three balls. They are circulating with three different radius but same time period. So which ball will have greater angular velocity? The answer is angular velocity is same for all the balls because their time periods are equal. The equation for angular velocity is 2 pi over t. Since the time periods are same, the angular velocity will be same. What about linear velocity? Linear velocity will be greater for green colored ball because the radius is greater for that one. Calculation of angular velocity. Rotation of Earth in its own axis. So how will you calculate the angular velocity of rotation of Earth? So use the equation omega is equal to 2 pi over t. The numerator is 2 pi and the denominator is time period and the time taken is 24 hours. Change hours to second. You have to multiply with 60 and with 60. So the answer is 7.29 times 10 to the power of minus 5 radians per second. Hour hand of a clock. So to complete one rotation, the hour hand of a clock will take 12 hours. So to calculate omega or angular velocity, use the formula 2 pi over t. And the denominator is 12 into 60 into 60. So the answer for angular velocity is 1.5 times 10 to the power minus 4 radians per second. And there is no change in the numerator. It's 2 pi. Another example. A ceiling fan with 300 rotations per minute. So in previous questions, there was only one rotation. But here 300 rotations are there. So you have to use the total angle. So equation for omega here it is total angle divided by total time. So here 300 rotations are there. So it is 2 pi into 300 divided by 60. Careful about the numerator. The answer is 31.4 radians per second. That's all for today's lesson. Thank you all for joining. Stay safe and have a good day.